busting the myth of the 28-day menstrual cycle. Most of us are taught at school and in medical textbooks that a woman's menstrual cycle is normally around 28 days, and ovulation, which is when an egg is released from an ovary, happens on about day 14 of the cycle. But actually, this general rule of thumb is way too simple. The truth is that a woman's cycle length can vary a lot from cycle to cycle and between women. Cycle patterns may be different according to someone's age, weight, and other things. With the rising popularity of mobile apps for personal health monitoring, including cycle trackers and fertility monitors, women can now easily get to know their own cycles. They can identify when they are fertile, either to avoid or plan pregnancy, and if a woman has unprotected sex during the fertile window, that is, the 6 days up to and including ovulation day as shown by the app, then there's a good chance of becoming pregnant. Researchers at the fertility monitoring company Natural Cycles, together with academics at University College London and Karolinska Institute in Sweden, published this landmark study on the menstrual cycle. Dr. Jonathan Bull, a senior research scientist at Natural Cycles and the lead author of the study, and his colleagues looked at a huge dataset collected from users of the app. They set out to measure the length and characteristics of over 600,000 menstrual cycles from nearly 125,000 women using the app to debunk the idea of the standard 28-day cycle once and for all. The Natural Cycles fertility monitoring app works by users measuring their body temperature and entering it into the app. They also record when they're menstruating and have the option to enter hormone test results. At the end of each cycle, a complicated calculation or algorithm uses the temperature measurements to calculate on what days the woman was most likely fertile in that cycle. It works by detecting a clear rise in body temperature on ovulation day when the egg is released from the ovary. The algorithm also predicts what day she will likely be fertile in the next cycle, taking into consideration a margin of error. As a woman records more cycles, the algorithm becomes better and better at predicting the fertile window. If temperatures are recorded on or over 50% of the days, the predictions are much better. Less frequent measurement may mean that ovulation cannot be detected. In some cycles, ovulation may not happen at all, and this can also be detected. A downside of this study is that all data was self-reported by users and not collected by medical professionals, so its quality or accuracy may vary. On the other hand, the huge amount of data meant that Jonathan and his team could filter out poor quality data and still had a very large group of people's data, or sample, to work with. Women included in the sample were aged 18 to 45, of all shapes and sizes, with a body mass index, BMI, between 15, which is severely underweight, and 50, which is very severely or morbidly obese, and had recorded at least 6 cycles each. Most of them were residents in the UK, USA, and Sweden. They took data from high-quality cycles where lots of measurements were recorded and ovulation was accurately detected. This made sure that the results were scientifically sound and reliable. The study found that only 13% of cycles fitted the standard picture, 28 days long. The average length was actually 29.3 days, with ovulation on day 17. 2/3 of women had cycles of 25 to 30 days, and 1/3 of women had so-called abnormal cycles, so either really short or really long. There was a really strong age effect, where cycle length decreased a day every 5 to 6 years of age, from 25 to 45. It was caused by ovulation happening earlier and earlier. We also saw a strong effect of BMI. A woman's cycle length was more variable if they had a BMI below 18.5, so was underweight, or above 35, so was obese. These results have been shown before in other studies, but this was the largest and most detailed study to date. This work was important for several reasons. With more and more women using cycle tracking apps, it is vital to shed light on how varied their cycles really are. Some standard tracking methods may miss or inaccurately predict the fertile window by not properly taking into account the variation of a woman's cycle. Temperature-based methods reliably find the window with better outcomes for women and their partners in terms of whether they want to prevent or plan a pregnancy. With more couples delaying starting a family until their mid to late 30s, when female fertility is already going down, fertility monitoring apps can help increase their chances of conceiving. This study demonstrated that high-quality science can be done with self-reported data gathered remotely via an app. A much larger population can be examined than in a standard medical trial, and it was a milestone in the field of women's health research, which traditionally has been underfunded, but is now experiencing an explosion of interest and investment. This should now lead to further research.